Hi everybody, welcome to the webinar. We are very happy to have this session today with the Aplitop team. Let me introduce the people that will have the webinar. So we have George and Francisco that are software developer engineers in Aplitop. And then Chiara Ponti, she is the product specialist for 3D solutions in Stonex. So just a couple of information about the system. Go to webinar, Chiara.
Okay, thank you. Hello to everybody. Yes, just before starting, for those who are not familiar with the platform, in the upper part of the screen, you have the possibility to change the layout of your visualization. In particular, you can decide to show all the active cameras or just the ones of the people who is speaking. I recommend this option, especially for seeing better the sharing of the screen that will happen during the webinar. And then also another option that you have is to change the camera positions. I suggest to put them on the sides also to gain space with the sharing of the screen. Another option that you have is to pin the cameras or the screen that is being shared. So I recommend to pin the screen so you can see better the presentation and all of the cases that we will share today. In the upper right part of the screen, you will find a question box. Here you can ask your questions during the webinar. Maybe we can answer to some of them, or at the end of it, we will choose a couple of questions. After the webinar, if your question is not being answered, you will be contacted with the answer. Okay, so I think we can start, Federica.
Yeah. Sorry, I forgot also to introduce you Francisco, the CEO, and Felipe. They are also from Aplitop. They will also join the webinar. So yeah, we can start. Just a couple of slides introducing the two companies. Yeah, first of all, an overview of what we are going to see today. There is a webinar introduction in which, again, we are going to introduce the two companies, and then we will go deeply into some case studies that are focusing on some surveys made with our Stonex SLAM and Stonex XFly, the UAV solution. And the data coming from those devices are processed, and some deliverables are created using Aplitop software. At the end, we are going to close the session with some learning resources and other information, and with the answer to some of your questions. Okay, so talking about Stonex, we are a company reselling worldwide. We are based in Italy. We have a big network of distributors all over the world. And we are manufacturing, measuring and surveying devices, from GNSS to total station, tablet for managing your field surveys. We have dedicated software in the field, and we have also two divisions dedicated, one to the 3D surveys. So what we will see today, the topic that we will see today, and we have a wide range of SLAM devices. And then also Stonex is distributor for machine control solution. About the 3D solutions, we have a very wide range of SLAM products. You will see later we have different devices covering different application and customer needs, using different sensors with different ranges. And besides the SLAM products, we also have a UAV solution for surveys from drones. And we also have Visual SLAM handheld scanner that works, its technology is based on photogrammetry. So it provides very high resolution details. You have many more information about our products on the web. About Aplitop, Francisco.
Thank you, Federica. Hello, everyone. It's a pleasure to be with you here today. I would like to thank you, Stonex, for this partnership and the opportunity to work together to develop and to offer to customers a powerful and easy to use solution for their customers. Aplitop is a company based in Spain with more than 20 years experience developing software for surveying and civil engineering. Our product range come from data collection software from connected with GNSS to CAD-based software for civil projects, tunnel applications, and of course point clouds. We have a strong distributor network with more than 80 countries. Our software is being used in more than 80 countries and is trusted by thousands of users all over the world. We expect you enjoy this webinar. Thank you.
Okay, so yeah, as Francisco has just introduced, we are very happy about this partnership because together we can deliver a very good solution. You can have surveys using a Stonex scanner, and together with a software like Aplitop, you are able to get all the deliverables and all the outputs that you may need in your daily work. So before starting, I just would like to share a quick survey. The first one is about we are curious to know if you already own a SLAM scanner, and in case you have, if it's a Stonex product. Okay, so I see that you are still voting. Okay, I'm happy to see that many of you already have a Stonex SLAM laser scanner. Many of you don't have such a solution. Okay, thank you for your replies. And I like also to share a second question that is more related to the software. So which is the main product that you want to deliver from the point clouds between plan and elevation sections, 3D CAD drawing, digital terrain model, or point cloud web viewer? Okay, I see that many of you are choosing for the 3D CAD drawing, more than the 50% actually. Then we have around 25% needing a digital terrain model, 13% plan and elevation section, and around 10% point cloud web webinar. Thank you for answering to this survey. Okay. Chiara?
Okay, Federica, I think we can start with the core of the webinar. Thank you. Okay, so now we will go and see some case studies that we surveyed with our SLAM scanners, with our 3D products. And in particular, starting from our point clouds, we will see, thanks to our friends of Aplitop, how to integrate this data in a real project and what we can do with Aplitop tools in TCP Point Cloud editor software. So let's start with the first case. The first case is about forestry. We made a survey with our SLAM scanner X120 Go and our UAV LiDAR solution XFly together. It was a combined survey in the northern part of Italy, and specifically in the Dolomites, which is a very nice place. The goal of this survey was to map and to understand the forestry asset of this area and to perform some terrain analysis, in particular for the estimation of the biomass that can be extracted from these resources. So we combined together two scans. The dimension of the survey was approximately 6 hectares, and we obtained a precision around 3 centimeters, combining the two data sets. So with the XFly, we made a very short fly, about 8 minutes of flight, collecting this data at a height of about 80 meters. And with X120 Go, we performed the survey around the trees of this area in about 10 minutes. So I leave the word to the more expert speakers that will explain to you how to use this data in Aplitop software.
Hey, thank you, Chiara. Hello, everyone. I'm Francisco Vázquez, software engineer here at Aplitop. And yeah, let's begin with the use case and let's see the basics and how to do some ground extraction and terrain modeling. So, first of all, we have to create a new project. So we call it something like Forestry. And here we have our empty project. So we're going to go to point clouds and just import our dataset. So here we can see we go to our folder here and we have the two last files, the one from the XFly and the one for the X120 Go. And we add them and we can see here all the available formats that we support in the application. So you can work with last file A57, PLY files, we can file LGSX, and you can even import ASCII files and set up the column configuration, the limiters, and so on to use a custom format. And we add those files and import them. Okay, so now we can see here we have our points in the application. We are watching in the viewer. Our next step will be to analyze and check the information we're given. So we select both of the point clouds and check their properties. And here we can see that we are talking around 135 million points. And we can see the bounds of the coordinates here from the point clouds. And most importantly, here at the bottom, we have all the attributes that were detected during the import process. So in this case, we have everything except categories, except classification. We have color, we have intensity, the timestamp values, and from the LiDAR, we got the return information from the LiDAR. So if we want, we can go into the details of any of these fields, and it can show us for continuous values like intensity. It will show us an histogram and so the distribution of the values of that attribute. So we can see here how the intensity is in this case. And if we go to a discrete value like the return info, we can see the classes of returns like unique versus of many, or less of many, and how are distributed along the point clouds in this pie chart. With the classification, which is also a discrete, will be very similar. Okay, so now we know what we have available. So our next step will be to uh, do a quick visual analysis with the different symbologies to check for issues or how to clean the point cloud to get the ground. So let's start with the cloud representation. And as you notice, we have the both of the point clouds, and they have those colored rectangle, which is the color that represents that point cloud in the project. So when I go to cloud, you can see the yellow point cloud and the red point cloud, which represent the X-Fly, the yellow one, and the red one is the SLAM one. So we're going to enable the EDL to not see everything flat. And we can focus here to see in more detail the SLAM overlapping the LiDAR dataset. We can even hide the X-Fly, for example, to better see the SLAM one. And we're going to use them as a single point cloud in this case, just to use the reinforcement given by the SLAM dataset to get more ground information in that area. And here we can also see the return data. This is with the class of return. So the blue ones are the unique return, as you can see here in the legend. And the yellow ones are free of many, and the red one are less of many. As we have two returns, there won't be intermediate in this case. And we can also analyze the intensity. For example, we can go here and set the representation, and we can configure all the colors and the distribution as we want. We're going to tell it to use 100 ranges and distribute it with quantiles, which is more accurate for the intensity values. And here we can see the values of the intensities. This can be useful to detect when you have a very reflective area and you have like a hole in the point cloud. This is very useful because you will see a very bright ring around the hole, so it's very easy to spot this kind of things. And now we're going to go to the elevation map. And here, this is going to help us to detect high and low noise. We're going to see now, we are going to configure at 20 ranges with this color palette. Of course, we could change with any of these pre-configured color palettes or change here any color we want. We can set up this as we wanted. And now we're going to see that we can see the 20 colors well because we have a noise at the top. Likely, this confirms that at the bottom we can see the magenta color. That means that there are no low noise. That's very good because low noise makes harder to extract the ground, and we have to clean that very well. So now we are going to handle the cleaning to get the ground. First thing we're going to do is get rid of all the points that we know for sure that we don't need. So these top points here of noise, we can just simply zoom a little bit and make a broad selection, taking care of not selecting any of the actual point cloud for not losing any detail. And all of that noise directly remove those points. So that's the way the application works. You make a selection either manually or with any of the filters or any tool. And once you have the selection, you decide what to do with that. You set a category, you delete, make a filter, hide the points, whatever you want. So Now we're going to use the return information because as we are looking for the crown, we know for sure that intermediate and first of many can be ground points. So we are going to directly select them and we're going to get rid of them. And also with this, we're going to reduce the number of points and make the rest of the process a little easier for the computer. So now to get rid of the rest of the noise points that we see here, we could do it manually, but it will take a lot of time and we have to be very careful. So instead, we're going to use the isolation filter. What we're going to do is find points which at the radius of 0.2 meters don't have at least two neighbor points. If that criteria is not match, we're going to consider that an isolated point, and we're going to select every one of them. And we're going to see here all the noise points are selected, and also at the borders, because we don't have as much density, are going to select a lot of points also, and some between the trees, which is to be expected with the vegetation, but it should be okay also because we are looking for the ground. It won't affect for further calculation, so we're going to just remove them. As you can see, the vegetation looks almost the same, but we got rid of all the noise. And now we go to the ground extraction. So for that, we have a special filter, which is called a CSF or close simulation filter, which is this one over here. And this filter will uh, find the ground by making a grid with a point cloud inverter on the set. So it's very weak against low noise points, and also at the borders you're going to see, because we don't have so much density and we miss the ground points, there is where we can have more issues, but we'll fix it later. So we run the filter at a resolution of 0.2 meters and let it work to find the ground. And now we can see selected all the points that it considered that are not ground points. Let enable ideal again. As you can see, all the vegetation is selected, also some of the low vegetation. This filter let's invert the selection to select the ground. And also this filter can have issues when the slope is very strong, very steep. Like in here, for example. So let's very quick fix this with a manual selection and add these points back to the selection. Okay, so now we have the ground selected, so we move all those points to the ground class. And now that we have a classification, the category representation is enabled. So we can switch and we can see of the white points, which are the ones non-ground, and the orange ones, which represent the ground. And we can go here to the property of the classes, and we can enable or disable points of any of the classes, so we don't see them. And also with this column here, we can tell it if we want to triangulate those points. What that does is it doesn't matter if they are visible or not, they won't be considered either for modeling or for a profile computation. In the profiles will be ignored also. So we hit OK, and now let's check the ground that resulted from the raw filtering. And we can see that we still have some points of vegetation here. So we're going to fix some of them by manually selecting and removing the points. And also remove all this over here. And also another way of cleaning the point cloud could be like this. We can go here and we can see here it seems to be like car parts from cars that were in that road. So we can do a profile here from the top view, and with the dynamic assignment, I'm going to select the bandwidth by selecting points graphically. And let's make sure that in our profile we take those points. And here we see the points profile. And directly in the profile, I can make a selection, take all of those points. And I can see also here that there's some vegetation. I can select it also. And you can see that in the 3D view, the points are also selected. So the profile and the 3D view are linked, and I can make even decisions with the selection in the profile itself. In this case, we're going to switch this to the never classified class, which is the non-ground class for this case, and move those points there. And because earlier I disabled that class, the points disappear, and we fix those areas. So with a combination of keep applying the CSF filtering in localized regions, manual filtering, and using the profile as a reinforcement, we can clean the ground and get something like this. And we can now even show the rest of the point cloud to see everything, as the non-ground points are not triangulable. No issues with that. You can see here the full result. And finally, we can go to modeling and create our digital model. So we have two ways of creating models. We have the elevation map, which creates a grid of heights with squares, or a triangulation. In this case, we're going to use a triangulation because, as you saw earlier, by the cleaning process, we get holes because the low vegetation and so on. There are places where we have no ground information. So the grid can fill those holes by interpolating the vertices, but it's most costly and it tends to be less precise that let the triangulation works. Triangulation is better for this kind of data. So we're going to use a resolution of 0.25 and a maximum edge of 25 meters around the contour. Here we can also have the option to include a contour for the triangulation with a 3D polyline if we want. And even we can have in the project, in our drawing, break lines, 3D polylines of break lines, and introduce them into the triangulation to supply missing information and things like that. If, for example, when we are modeling something that has like a road and we want to have very clear definition of the road lines, that's a way to do it, to do a polyline and insert it. So here we have our triangulation. As you see here, we can change its representation similar to point clouds. It's exactly the same. We have the model, which is a flat color, the elevation map, and a slope map, a slope direction map, and even we can import an orthophoto and texturize the model with the orthophoto if we want. Okay, so that's our model in completely solid. And now we can compute the contour lines. So we're going to use an interval of 1 meter for minor contour lines. And for the major ones, we're going to use 5 meters. And let's compute the lines. And here you can see the contour lines. And if we zoom in, you can see, and this will happen always, there will be like little spikes in the contour lines, which is inherent to the way that point clouds work, because we always have some a kind of margin of error in the point cloud, and the surface captures everything as it is. So a quick way to get a better looking contour lines is we take the surface and we convert it to a data elevation map with the same cell size as our minimum edge length. Okay, so here we have our grid. The grid works exactly the same as the surface, and we can smooth the grid. So we give it for the smoothing a radius of a little more than the cell size and 2 iterations, just a touch. And here we have our smooth model. You can already see that a lot of the bumps are smoothed out. And if we compute the same contour lines from this model, you can see that we have a much better looking result. So, of course, this can be a destructive process and you could be afraid of losing the real information from doing that. How can we check that we have not given too much smoothing with making a profile? So we enable everything, and we're going to set up a quick profile in the top view with a resolution of 5 centimeters. And we're going to follow this row over here. And as you can see, now we are seeing the section all of the elements. We have the point cloud, the smooth terrain, and the original terrain. The yellow one is the original, the red one is the smooth, and we see the points at the background. And we can check here how the surfaces adapt to the original ground, and we can even make just here and take measurements. We can see there's a diff of 1 centimeter, and if we measure here, we can see that there's a difference of 7 millimeters. So like that, we can check all the elements we want in with any section, and we can see the result. And here is the final product with only the ground and the final contour lines. Okay, so that was for this case. I'll let Ciara take the word back to introduce the next use case.
Thank you, Francisco. Now we move to the second case. In this second case, we will explore a point cloud of a train station here close to Milan, where our main offices are located. In particular, this scan was made with the X70 Go with the help of one of our accessories, the panoramic camera that allows you to generate 360 degrees images that can also be integrated in the point clouds resulting from the SLAM algorithm. So in this case, we made a single scan of about 20 minutes length. The survey area was quite big, but we managed to reach a precision of around 2 centimeters as a global accuracy. And now in the next case, we will see how to deal with this data inside of Aplitop software.
Okay, thank you, Chiara. Let me start the case. Okay, so we already have the project created. We have the point cloud already in the project. And let's go to the imagery tab and let's add the panoramic images. We have a few options to do that. We can get them from the A57 file. In this case, will be the one that we use because in the same file we have the images and the scan. We could use LGSX, or also if for some projects and so on, we can go from the GoPost project directly and import the panoramic images and the image positions from the GoPost software and create a path in the project for this that scan. Okay, so let's find the E57 file, which is over here. And as you can see, it analyzed the file and it get us the structures of the file, so it can get all the setups, all the scans, and all the images related. And also the software finds those scans in the project and bind the image to them. So if you make some transformation on the point cloud, or you are traveling from one panorama to the other, it will automatically make everything right, like move the point cloud along the images, and also be able to show only the scan that is bind to the panorama image. Okay, so we have all the images imported. We can check their properties, and we can see a preview of the image, and we can see the resolution, the size of the image in bytes, and here down we can see the pose parameters, so the orientation of the camera, the position, and the kind of projection from this image, which in this case is a spherical panorama, and the pixel size of the image. So now what we can do is we can enter into this building, into this train station. We're going to switch to perspective view so that we can see more clearly. And all of that red bubbles are the scan positions that we got from the E57 that had the panoramic image attached. So I can click on any of the bubbles. It shows me a preview, and I can enter the panorama. And you can clearly see that we can see the image, and the 3D view is synchronized. I can jump to another bubble, and I can inspect the train station going from image to image. We can also go to this upper part of the station where the rails are and do the same thing. We're going to enter the perspective view, go to the rails, open some of the bubbles, and we can inspect also here the upper part with the rails, the trains, and so on. Jump from bubble to bubble. And now here, inside the station itself, we're going to open this bubble here. Here we can see these vending machines, the staircase, so on. And we have like here at the ground, that makes the points bigger to see better. And we can see here at the ground that we have like this kind of rail here. And actually, in this view, we can switch the point reference here, and we can see this slider which represents that the opacity of the image, because the actual point cloud is behind the image, as you can see here. Okay, so with that, that means that we can, for example, take a measurement directly over the image because it used the points behind them. And you can see here that makes the measurement, and in the 3D view, the measurement is at the right place. We can also go, for example, to this machine here and make this 3D measurement that also shows us the horizontal and vertical difference. We don't see clearly because of the red. Well, we go to the layer properties, change the color, change the line width, and we can see now in magenta and with the lines more thicker. And of course, we could also make drawing directly over the image here. We can follow, for example, the edge of the staircase here. And we place our vertices here. And you can clearly see here, the line is there. And if we go to the 3D view, it's hidden because of the point cloud, but if we keep the drawing visible, you can show the line in 3D at the right place. So now we're going to isolate this part of the station, and we're going to extract do some vectorization by using the sections. So with this option of coplanar cuts, we can get cuts from the top view or XY planes at different elevations. So to set up the range, we can see at the bottom bar that it tells us the coordinates of the cursor. So we are going to look for the floor and the ceiling to only get the entire building. And we set up the values there. 1.5 foot the max, and we start at -1.75. And we're going to make code cuts each 25.25 meters, and with a band height, which is the bandwidth of each of the planes, of 0.1 meters. Okay, so we make the cuts, and the profiles viewer opens, and we can go see here the different uh, sections. We can navigate from one height to the other, and we're going to work over this one, the division 0, and we can add a layer, call it walls, for example, and set it in this light brown color, and a columns layer. And now over this section, we're going to draw the walls, and we're going to draw the shape of the columns. We have to be more careful because they have like this oval shape. Okay, and now that we have that, we can go to this button here, which is called transfer, and it will transfer those entities back to the 3D world and unproject them. A cool thing is that this works no matter how the profile is done. In this case, it's an SY plane, but even in the previous example that we did a road, it also projects it. So we transfer the entities back, and when we go to the 3D view, we can see that we have the walls and we have the column. So that's a way that using the sections to getting elements drawn into the point cloud. Now, we have this wall-friendly staircase here that we saw earlier in the image, and we want to actually model the staircase, and in this case, we're going to try to model it with 3D faces. So a way that we can do that is also with a profile. So the way to do that is we go to the quick profile, and we do a profile at the top with a bandwidth of 5 centimeters, for example, and we make a single cut that goes through the middle of the staircase. Okay, here we have the viewer, but we're interested in editing the profile. So we go to edit, and here at the editor, like we did before, we're going to draw all the profile of the whole staircase. So we're going to draw, and we're going to follow the path of the staircase by using the point cloud as a visual reference. And we draw the entire staircase. Okay, and now we are going to set the layer name to stairs, change the color, make it a little thicker, and as we did before, just transfer this polyline back to 3D. And as you're going to see now, here we have the polyline, and as we move the view, you can see there that it's following the shape of the staircase in 3D. And to get the 3D faces, we're going to select the line, go to CAD drawing, and here we have an extrusion tool, the extrude command, okay? And here we can tell it that we want 3D faces and give it a extrusion vector. So we are going to define it and use the entity snapping to get it right. So we are going to use the final point snap to get this vertex. And now we use the point cloud to get the edge. And as we know that is a flat surface, we're going to set the set at 0 for the vector. And we hit OK. And here we have 1/2 of the staircase. And we do the exact same thing for the other half. Zero and 3D faces. And here you can see that we were able to very easily model the staircase here in 3D. So I'll take the word back to Chiara to continue with the next use case.
Thank you, Francisco. Let's go back to the presentation and move to the third case. Now we move outside to a street, actually a street in Malaga, in Spain. Here, the survey was made with our SLAM scanner X120 Go. It was a single scan, about 200 linear meters of walk in about 10 minutes. And the goal of this survey was to map the area for construction and maintenance purpose on this road. So the words to you is up to you. You can show to us what you can do and we can do with Aplitop software on this dataset.
Okay, thank you, Chiara. So let me show the video. Here are the videos, and I'm going to show the urban outdoor study case. So we can see here that we have a point cloud in a raw mode. So the first step, as we have seen before, is to do a cleaning up of the point cloud. The idea is to get only the points of our area of interest. So the first thing we have done is selection by polyline and hiding the points. Now, if we inspect the point cloud, also we have a big problem that are noisy points under the ground. To avoid this issue, we can do a selection by elevation. With this tool, we can select an upper and a lower limit, and all the points in between will be selected. So the application shows in orange color the points that are going to be selected before you apply or accept. Once they have been accepted, you can hide them so all the points below the ground have been selected and removed. Next, we do a lighter version of the point cloud using the density filter like we have shown before. And this way we can see that parts of the point cloud are more dense than others. So the idea is to have an homogeneous point cloud with points separated or at distance that is more or less homogeneous. Next thing we do is do an isolation selection and filtering, because we have scattered points that don't provide meaning for our purpose. They don't define well surfaces or things like that. So the best thing is to remove also these points. So we hide those points, and once we have more or less a clean point cloud, we make a clone, a copy of this point cloud that will only have the points that we are watching now. So the other objective in this work is to have a classification. Now we are going to show the capabilities of classification over the raw point cloud. We see first that we have 2 point clouds, one that is cleaner and the other that was the raw, and one have a lot more points than the other. Anyway, with the artificial intelligence classification tool that will be included in the next release of our application, we are able to classify 2 models of a scene, outdoor and indoor. In this case, it's the outdoor, where we have several classes like ground, buildings, trees, and things like that. And also the model includes vehicles and street lining. So once we have classified with the tool, we can see the results here. In the distance, it seems good or good enough, but if we take a closer look, we can see that we have some mistakes or points that haven't been classified. So to avoid this thing, we have also developed advanced selection tools like the vicinity selection that is showing now, that allows us, for example, select an object that is vertical, setting that the point that we are going to click is the lower point, and it will select all the points that are connected with that point. This way, we can select this tree that was badly classified and choose as a classification like a high vegetation, and assign this classification to the selected points. This way, we can edit the classification manually, and cases that are harder, like this one, where we have 2 objects very close one to the other, we can use the clustering selection that also is a beta feature of the application, and also will be included in the next release of the application only for a time, and in the future maybe it will form part of a professional version or something like that. And with this tool, we can select the light street that is closer to the tree, and only the light street is selected. As we have done before, we can choose the class or classification we want to assign, and this way we assign this classification. This is the final result of the point cloud classification manually and automatically. So at the end, we can hide or show different classes, and this way we can inspect the area and view what elements are. For example, we have for manual classification, we have added a few more classes that we will try to add in the future to our intelligence model to detect or to classify. And that's all in this study case. So, Chiara?
Okay, thank you, Jorge. Back to sharing the presentation for the last case of this webinar. Now we move to the office building, to an indoor office building, and in particular we will see how to manage data coming from our scanner X40Go with the use of geotags. So in this case, we made a single scan of about 10 minutes, and with the use of our Go app, we were able to also take some photos as some elements that are present in the area, and to use them for example, for facility management. In this case, we focus on emergency exit, fire extinguisher, all of the elements related to emergency plans and so on. So now the words to you, Jorge, so you can show the examples with this point cloud.
Okay, thank you, Chiara. I'm going to show the last study case. In this case, we have also a point cloud that is bigger. It has 80 million points or something like that. So the first step, as we have seen before, is to reduce the amount of points and also to remove all the noisy or the not well scanned areas that we understand that are not part of the job. So, for example, with simple tools like polygon selection, we can select those areas and remove it quickly and easily. So I have also resumed this video in order to be faster and to avoid things that we have seen before, like is removing all the points that are inside some areas that are not of interest for us. We can see here that the initial point cloud has 87 million points, and at the end we have only a clean point cloud of 23 million points. Now we are going to show the automatic classification for indoor scenes. We have trained the model of artificial intelligence to recognize different elements of an indoor point cloud. So we have selected only a part of the point cloud that have the ceilings, the walls, the floor, and also mobiliary or elements like chairs and tables, and also windows. So the first thing we do is in this point cloud that is unclassified to create the categories that we are going to map from the artificial intelligence algorithm to the last categories that are the categories that our application is able to understand. So we can see that we have not categories yet. So we configure the automatic classification that is a beta feature, as I have said before, to select the indoor model and to map the classes that this model is able to recognize. Once the process finish, we will see that we can see this point cloud using the categories. So we are able to hide some of these categories in order to have a better look. In this case, we can see inside, removing the ceiling or hiding the ceiling, so we can check that the tables and the chairs and also the windows are classified. The white points are unclassified points that the model is unable to classify, but we will try in the future to have better classifications with more elements. Now we are going to share to show how to classify but manually. The question is that, as we have seen in the case before, we have classical techniques or methods to select, like this one that is select by elevation. So we have developed a quicker way to do this kind of selection of flat areas or plain areas that only clicking once, the application is able to recognize the plane that is in the clicked area. So you can select it very quickly. So you get all the ceilings, for example, and you choose this classification and set the classification for this selection. In the same way, we can do that for the floors, and even something that we can do with the elevation selection is to select the walls. This way, we can select the same tool of estimated plane, and using this tool, we can select all the walls that are more or less planar. Okay, we assign this classification, and next we go to do the selection of the interior elements of the point cloud. In this case, we can see that hiding the ceiling and the floor, we are able to watch that there are tables and chairs. Using the vicinity selection tool, we can select elements that are connected and are very close, the points in this group of points. So this way, automatically and later manually fixing the errors or the things that are not uh, classified, we can do a full classification of the point cloud. We can see a preview of the structure that is the objective later to do a CAD drawing. Now, we are going to show you the geotags functionality of the application. This is the point cloud, and we are going to insert or create a new geotag, and this dialog is shown where the user can set the name, a type or class of tag, description, and also can include an image or a document or even a web page uh, to access the information related to these geotags. We can edit this or add or change some of these properties. Also, we are able to import from LGSX files or CSU files this kind of information, geotags, so we get the geotags load in our project. So we are able to watch the different elements that Chiara has commented before, and we can see the fire extinguisher or the exit, the emergency exits. With this manager, we can handle or manage the tags. So we can locate the position of one of the geotags and see that is well placed and is referring to the thing that we have in the image. Using this manager, we are able to remove geotags that we have, and also we are able to export the geotags to a file. There is no standard, but we have agreed with Stonex some structures in these files in order to provide enough information about the geotags. Next, we are going to see the CAD capabilities of Point Cloud Editor. So we only select the walls that we have classified previously. The idea is to get a floor plan and later to make a drawing with different layers with the walls, the windows, doors, etc. So the first thing we can do is to draw directly on the point clouds using the reference to point. So this way we can draw a 3D polyline and close it. So we have draw the area of one part of the point cloud. As we can see, the height of this polyline is arbitrary. It depends on the point clicked. So we have different options to set the height of this polyline. In this case, we use the rectify feature. This rectify feature will take the height of the closer points in the point cloud as the vertex height. So we can see that the polyline is well aligned with the point cloud. Another way to draw floor plans is using the raster editor feature. With this raster editor, we get an image of the point cloud from top view. So we are able to draw over this drawing. We can import layers from the point cloud editor to this editor in order to see or to watch the lines that we have created previously. And we are able also here to use several tools that for questions of time we cannot extend the explanation, but we can draw polylines here and also auto detect polylines and join lines and things like that. Once we have created several polylines here, we can send those polylines back to a point cloud editor. So we can choose an existing layer or even create a new layer where these polylines will be added. So when we go back, we can see that the polyline we sent to the editor is shown there over the red polyline, and also the new polylines we have added are here. So the repeated polyline is deleted in this case, and the other polylines are going to be sent to the floor plan layer. So this way we can see that it changed of color, and also we have to fix or to set the height of this polyline. This time we use the flatten entities tool that allows us to set the height of all the vertices to the same value that we can pick from the point cloud or from another entity, or also we can write it in the dialog. When we have modeled all the floor plan, like we can see here, we are going to see how to draw a vertical element like could be the windows. In this case, we set reference to a plane. This tool allows us to define a plane using only 3 points. So this way we are perpendicular to this plane, and all the entities that we draw here will be drawn over the plane. So for example, we can draw a rectangle, and once it's drawn, it's over the plane we have defined previously. We also can use the copy functionality and copy this entity again over the same plane. So as we will see in a moment, those polylines are over the plane. So this way we can draw all the vertical elements, for example, that are on the walls, like windows and things like that. And we can see that the full model is drawn this way. We are going to change again the height of this layer in order to draw the walls of this building. In this case, we are going, for example, to copy this line. So making a copy and setting it to the height of the bottom part of the point cloud, we get a copy, and again we can move this new entity to another layer. In this case, we are going to send it to the walls layer in order to make an extrusion. Using the extrusion tool, like we have seen before in Francisco's example, we can create new elements in a very quick fashion. So we have more or less the structure of the walls in this area of the point cloud. So if we turn on the layers that the application has, we can see several elements that we have drawn before. This is the full result of the job. So we have a point cloud fully classified, and also we have the full drawing or 3D models that includes a floor, walls, windows. Also, the ceilings have been modeled here. So we can see that very quickly and easily. We can do the classification that will allow us to make a better 3D drawing, and we can also inspect the results, turning on different categories or even the full point cloud and only see the 3D model that has that we get as result of this job. So the application allows us to export the drawing or the CAD drawing that we have created, and even it allows to import another drawing. So if we have a scanned building and also we have the drawing that has been planned before, we can compare if the 3D model of the drawing is the same as reality that we have captured with the scanner. So this time we are going to show that we can import that, and the result is the same because the save and load capabilities of the application works. Also, the application has a functionality to connect to a CAD drawing, to a CAD application, where we can interact and sending or transferring entities or layers, or even setting the same point of view. So at last, we can also publish the results of the job to share them with others that work with us. For example, in this case, we are going to upload to the platform the point cloud and also the drawing. So in this dialog, you fill the name and the author, a description of this point cloud, and also the content that you are going to upload. When the upload process has finished, you are shown with a link in order to inspect this result, and also to send this link to others so that they can examine or examine and test the results that you have get. So I'm going to share with you this link in the chat area. Let me do that. So I'm going to share with all this link. So if you use your web navigator to go to this web page, you can play with the point cloud and also with the drawing. There are tools for measuring distances and also to get profiles of the point cloud. So it's very useful. And I think that that's all that we have to say now.
Okay, thank you, Jorge, and thank you also to Francisco. I take back the word just to conclude the webinar with some information about where you can find useful material and where you can download a trial version to try and to test the software if you already don't have it. You can download from Aplitop web page a trial version of the software, just filling out the form. And again, in the Aplitop web page, you have a complete video library dedicated to all of the software that they have, including TCP Point Cloud Editor. With a lot of video tutorial, very explanatory, with a lot of details, and many information that can help you with managing all of the different tools that we have seen today. A lot of tools that can really manage very different situations. Okay, so talking about our part about Stonex, we can offer some bundles with our SLAM instrument combined with the TCP Point Cloud Editor. So if you are interested as a customer, you can find on our website a map with all of the dealers that can provide you with this solution. And so, if you are interested also in trying the software with some of our data from our scanners. So, I think we have reached more or less the end of the webinar. Maybe if you would like to stay 5 minutes more, we can answer to one or two questions if there are any interesting questions. Okay. Maybe I start with a couple. Some of you are asking if you will receive a copy of the webinar. Yes, we will send a downloadable registration recording of the webinar, so you can watch the webinar in the future. Okay, maybe I don't know if any of you guys from Aplitop have seen any interesting question that you would like to answer to the crowd.
Hi, Chiara. There is a question from Tony Hargan. Any plans to link software to GNSS and Total Station? Well, in fact, this application, Point Cloud, is mainly designed for working with point clouds, but we have other solutions working can work with GNSS and total station data. It's an application called MDT, TCP MDT, that runs on CAD, and they are fully integrated with Point Cloud Editor. So you can work with this data in this application and then exchange data with Point Cloud Editor.
Okay, thank you, Francisco. Okay, any other question you would like to answer? Maybe, I don't know, dedicated to some tools?
There is another question about mesh calculation. Yes, this tool, Point Cloud Editor, allows you to compare two surfaces or two meshes and compute cut and fill volumes. And generates also a report and even draw with a different palettes the cut and fill areas.
Okay, perfect. We couldn't show all of the functions included in TCP. There are a lot, but we tried to summarize with these case studies the most important ones. Okay. Federica, I don't know if you want to add something.
Yeah, there are some questions related to the format, the compatibility between Stonex devices and Aplitop. Actually, Stonex LAM and XFly deliver point clouds in LAS format and E57 format. The E57 format you saw also already includes all the panoramic images. So it's very easy to load these formats in Aplitop. Those are common standard formats. The only part we work on for the compatibility is related to the geotags feature. But the format that you export from GoPost, that is the software used for processing the SLAM data, is fully compatible with Aplitop. I guess you only need to have the last version of Aplitop. Is correct, Francisco? So I
Yes, it's
suppose
correct.
the maintenance plan should be working.
Yes, it's correct. We are going to release this new version that we have shown, including AI classification, in about 2 weeks. And then all these the features you have seen will be included in this new release.
So you only need to have the maintenance plan from Aplitop working.
Yes, in fact, if you purchase a new license, this feature is included, or of course, if you have a previous license and you have purchased the maintenance, you will get these features as well.
Okay, all clear. Yeah, I think we have replied to all the questions. If we meet someone, we will reply privately. I think that's all. We thank you all for joining the webinar. We hope you found these features, this integration interesting, and hope to see you soon.
Thank you very
Thank
much.
you.
Bye.
Bye
Thank
bye.
you. Thank you.
Bye
Bye-bye.
bye.
Thank you.